Hello, and welcome to today's probability lesson where we're going to talk about a binomial probability problem. In this problem, a class has 5 students. What is the probability that exactly 2 of the students, and the word exactly actually becomes pretty important to us as we do this. So the word exactly would be important as to whether we're using a binomial probability or a cumulative binomial probability. Exactly 2 of the students were born on a weekend. Now, to see if this is a binomial probability problem, the other thing has to be true is there's only 2 choices. You got what you were looking for, you didn't. You're not concerned with whether they were born on a Monday or a Sunday or a Tuesday. You're concerned whether the day was a weekend or not a weekend. So the probability of being born on a weekend, and we define the weekend days, and that'll be our probability of success in this case, is there's Saturday and Sunday are considered weekend days, and there are 7 days in the week. So there's our probability. And so how many trials did we do? Well, that's how many students we looked at, how many students we asked. That was 5. And what's the probability? And that's, assume that's 5 out of many students. So this is not a this is an independent event. What's the probability? Exactly 2. So that means we want x to be 2. So if I were to look at all of the other things that are in that probability formula, Q would be 1 minus 2/7. From using the calculator, these 3 things on the left are all I need. And n minus x would be 3. Those are the other 2 things I would need. But for using the calculator, I am going to use, it is in the second, and you press the vars button to get the distributions. That's what DISTR means. We're looking at binomial probability distributions. And then you have to scroll all the way down to where it says A. And it'll say A, and it says binom PDF. That's a probability distribution, not a cumulative. The one under that says CDF. That'll be what we want to use if we say at least 2 students. But when it's exactly, you're using the one with the P. So what we put into the calculator is these values in some form. Now, depending on which operating system you have, your calculator may ask you directly for P, N, and X. Mine does not. I get this little, whoops, I didn't mean to do that, but I get, let me write up here. Looks like I have to pick the pen up again. I get something that looks like this when I press that, binom PDF. And then I get just an empty parenthesis. What I need to put in is n, comma, p, and I can put that in as a fraction. I can just do 2 divided by 7 there. I don't have to figure out the decimal ahead of time. It's better if you just put it in as a fraction. And oh, I'm sorry, that I didn't mean to say 2. And x, how many were successes? So the number of trials, the probability of success, and the number of successes. So in my case, I put in binom PDF 5, comma, and then I did 2 divided by 7, and I saw that. You don't have to simplify it for the calculator. It knows what to do with that. And then I did a 2. And I got a probability of 0.297. So 29.7% is the probability, or 0.297 is the probability that in a class of 5 students, exactly 2 of them were born on a weekend. If I changed this to say at least 2, I would have used the binomial CDF function, but I would have put in the same things. Okay, so that's a good example of a binomial probability. I will post some more of these, and I will post a cumulative one also. Email me any questions you have.